Hello folks, we are back with the next video. It is the exercise 6.2 and we are going to take the question number 13. Last we finished with question number 12. Now it is going to be question number 13. And in the question number 13, slightly different from the previous question that we did. In the previous question, they had given four subparts and then we had to show that where which of the function is decreasing, but here it's not like that. The next question, it says like this: on which of the following intervals is the function f of x equal to x raised to 100 plus sine x minus 1 strictly decreasing? So they give us different intervals, and on these intervals we have to check which interval is it strictly decreasing. That's what we have to find. So let's check where and how it happens. So let's write the function. Function is x raised to 100. This is our 13th problem. It is x raised to 100 plus sine x minus 1. That's the function. Now, in order to decide where it is going to be decreasing or increasing, our very first step is to get the derivative. So let's get the derivative first and see what happens. So the derivative f dash x. What happens to f dash x? X raised to 100, the derivative is 100 x raised to 99. Sin x, the derivative is cos x. And 1, because it's a constant, there's no derivative. So this is the derivative that we get for the given function. Now we'll take every interval and decide whether it is going to be increasing or decreasing. Like we can take the first interval, it is between 0 and 1. The very first interval that they give us is 0 and 1, and in this interval we have to decide whether it is increasing or decreasing. So let's check. In the interval between 0 and 1, for x belonging to 0 and 1, let's analyze. How is this going to be f dash x? 100 into x raised to 99. Now x can take any value between 0 and 1, means it can be 0.1, 0.2, 0.3, something like that. So anyhow it is going to be say 0.1 raised to 99, 0.2 raised to 99, 0.5 raised to 99. It will be 0.000, but anyhow it's a positive quantity. Our idea is to check whether it is positive or negative. So definitely it's going to be positive. So that's what we are checking. So for x belonging to 0 to 1, 100 raised to x raised to 99 is always positive. Why? Because that's how the values are. You're taking a value between 0 and 1, which is definitely going to be positive. So this part is going to be positive. Our next part is cos x. How is the cos x value between 0 and 1? So it's 0 radian and 1 radian. How is the value? So that is also positive, but then we'll make ourselves understand as to how that happens. Now we all know that pi radian is, and we know that pi radian is 180 degree. So 1 radian is going to be 180 by pi degree actually. So we are talking of 1 radian. So that means it's like 180 by 22 by 7. Pi radian is 180 degree. So 1 radian is 180 by pi. So that way it is 180 by 22 by 7 or into 7 and so on. So like that when we work, we'll have to check how is the value coming up like. So that in order to know how much degree it is, so that it will be easier for us to make the substitution and convince ourselves that cos is going to be positive. Anyhow, so let's check now how much is that 180 into we'll have to get that calculated. So yeah, we're trying to do this calculation. 22, so 22 5 times 6 times is 132. So you can have 5 times 110, so it's 160, and so 22 7 times 154. Yeah, and so on. It's just for us to get an idea. So actually this is 57.2 and so on degree, something like that, just for us to get an idea that cos is positive. That's why we're doing all this. We know that our value of x is between 0 and 1, that is 0 radian and 1 radian, because we do all our calculations in radians. So it is between 0 radians and 1 radian. But 1 radian is a new quantity for us, so we are not able to judge how cos would behave there. So for us to make ourselves familiar, we are trying to convert that 1 radian into degree. We have converted that 1 radian into degree and we have got it as 57.2 degree. So that means our x value is between 0 degree and 57.2 degree. So then in that case, we can definitely judge that cos x is going to be positive. Why? Because between 0 and pi by 2, we know all the values. 0 and 90, all values of cos is positive. So as a result, for every x that is belonging, so maybe you can say, for every x that belongs to 0 radian and 1 radian, cos x is going to be positive because of this 57.2. We have made ourselves understand that yes, it's going to be positive. So therefore, you've got 100 x raised to 99 positive. You've got cos x also positive. So as a result, automatically f dash x therefore is positive on this interval 0 and 1. So there it is, positive. So it's not decreasing. So therefore, if you want, you can write fx is not decreasing. They have asked us whether it is decreasing, so no, it's not decreasing. So also let's go for the next interval. The next interval that they tell us, it is pi by 2 to pi. They tell us that it is pi by 2 to pi. Same trouble is going to be there, because angle wise this is going to be convenient for us for substitution, but then x raised to 100 there, it is going to create trouble, that way somewhere it is going to be a problem. So this interval, to interpret and get it in both terms, there is the work. So here what we did is 0 1 we converted into degree 0 and 57.2. Then we got an idea as to how the function is. Here also between pi by 2 to pi cos, somehow we can interpret, but x it will be difficult. So therefore we'll have to get this converted in terms of decimal, and then understand what decimal it is, then interpret how the value is. So for that, writing pi by 2 is as good as writing 22 upon 7 divided by 2. So divided by 2, multiplication by the reciprocal. So it is 22 by 7 pi. So that becomes 11. Actually, you're between 11 by 7 and 22 by 7, which means 11 by 7. Actually, fraction is it doesn't give you a clear idea unless you get a decimal. So let's get the decimal. 22.7 we all know it's 3.14, but then 11 by 7, let's find out. 11 divided by 7, 7 1 times 7, 4 remainder. We can have a decimal 45 times 35 and so on, something like 1.5. Roughly, just to make things clear as to how the values will be, right? So therefore now we'll look at f dash x. Therefore f dash x we all know is 100 into x raised to 99 plus cos x, where we have to talk about each of them, whether it's going to be positive or negative. So for us, 100 x raised to 99 means x is taking the value. So x is lying between 1.5 and 3.14. Anyhow, it's a positive decimal. So that is why 100 x raised to 99. Maybe some decimal point answer, but then it is going to be a positive quantity because it's taking a value between these two. So that's positive. Now, for x belonging to pi by 2 to pi, which is a second quadrant, in the second quadrant cos is negative. So then in that case, we'll check how the values are going to be. Now, this also we'll always analyze that x 100 x raised to 99, though it is positive, we will also take care that x 100 raised to 99 is going to be a value more than 100. Why? Because this x, it's taking a value between 1.5 to 3.14. So as you keep squaring, it will be definitely taking values which are greater than 1 definitely. So this is some value which is greater than 1. So 100 into 1, the overall value is going to be greater than 100, because this x raised to 99 is going to contribute some answer which is definitely more than 1. And if you multiply a number which is definitely more than 1 with this 100, then it is going to give you an answer which is definitely bigger. So 100 into a bigger thing is going to be a bigger answer. So that is why this whole answer is going to be definitely more than 100. Okay, so that's our observation. And that observation has come because we have known that interval, that it is between 1.5 and 3.14. Even if it is 1.5 square, then it is 2.25. 2.25 multiplied by this is, you can have that decimal shifted, so it will become 225, definitely greater than 100. Like that, you can have some few values substituted and you can convince yourself that yes, it is going to be more than 100. So this part is definitely more than 100, and the x is, that is a bit challenging here. X is between pi by 2 and pi, which is the second quadrant, where cos x is negative. But here, more than negative, we have to also specify the values where it is going to lie, because then only you can decide whether it is positive or negative. Now, it is negative, of course, but then you can just check the values, how it is. Like cos, when we are in the second quadrant, suppose say you are looking at cos pi by 2 and pi. So cos pi by 2 is 0, and then cos pi it's -1. So therefore your values are going to range from 0 to -1. It is lying in that range. So that you have to specify that the cos x value is between -1 and 0. So then in that case what happens is, when you look at f dash x, then the f dash x values is going to be, say this, the cos x, the x ray 100 raised 100 into x raised to 100, that part is some value that is more than 100. So when you look at f dash x, actually this first part, it is something that is more than 100. It will be an answer which is actually something more than 100, and here it can be the least value that it can take is -1. So like that, no? Anyhow, when you judge, it is going to be a positive answer. So therefore it is definitely, it is going to be a positive value. Therefore you can have function is increasing, therefore fx is increasing on pi by 2. So that's a bit challenging. You have to get all things clear and make yourself explicit about your calculations and convince that yes, it is positive, and that's how it becomes positive. So that's the B subpart. Now let's go to the C subpart, where they give us the interval slightly better, reasonable interval, 0 to pi by 2. As I told you, this interval is okay for the cos, but for the x substitution, we need to diffuse this further and get it in terms of decimal. Only then we are able to work properly. Now pi by 2, we have diffused it. We have got it as 11 by 7, and that's actually 1.5. So this is 0 to 1.5. It serves both the purpose. So again, when we look at f dash x is 100 into x raised to 99 plus cos x. So let's take the value over here for x belonging to 0 to 1.5, suppose say. How will this 100 into x raised to 99 behave? It will be positive, definitely. Why? Because you're taking a value between 0 and 1.5. You can take 0.1, you can take 0.2, you can take 0.3, you can take 1.2, you can take 1.4. Whatever be the value raised to 99 is going to be a positive value. Multiplied by 100 is definitely going to be a positive value. So therefore, it's very clear to us that 100 into x raised to 99 is definitely a positive value in this range. Now, and then we will look at cos x. So for x belonging to 0 to pi by 2 first quadrant, we all know cos x is positive. In the first quadrant, cos x is positive. So that makes our work really, really easy. F dash x therefore is a positive quantity since both are positive. So therefore f dash x is positive. Now because f dash x is positive, so what will happen? The function is increasing. Fx is increasing on 0 to pi by 2. So now what they have told us in the question is find out which option is correct. And they ask us about decreasing. Where is it decreasing and which option is correct? So all this time the option A is increasing, it's not decreasing. B is increasing, not decreasing. C is also increasing, not decreasing. But D option, they have told us none of the given. So therefore probably we can take the D option. So the correct answer for the question number 13 is D. So answer is option D. None of these. because they ask us which is the correct thing. So the correct thing is going to be the option D, none of this. That's how it is. Quite challenging, this question, but you have to be clear about both. One is algebraic function, actually polynomial function, and the other one is trigonometric function. So the domain has to keep satisfying both those, and it has to be convinced to the examiner that yes, this is how it is positive and why it is, the reasons have to be really apt and proper. And so that one has to make once in the working, it should be clear so that the person who is correcting it will be convinced. So that's all about it. And then we have further questions that we'll be taking up in the next video. Thank you.